Why?
I like the new protection system on your laptop.
I thought it might be wise considering the nature of some individuals in this class.
How many rows? You know the heaters were on.
They weren't.
No, was on.
Oh! Ridiculous. Alright, we'll continue. Faisal! Sit down!
Transformers?
Yeah.
One or two. The movie.
Last night.
Faisal, 2 seconds.
Oh.
1, 2.
Yeah. Step up.
Lee! Lee! Omar! Yahya! Get in! Sit down on your chair. Pointing forward, please.
So we agreed to make it.
Sit down and be quiet.
Release the deal. No, it's not good for fun.
Why?
You want sleep at night?
Sit down.
Why?
What do you do? Leave Fong alone, okay? They are jealous of you because you're so smart at chemistry.
No!
Yes.
No!
Yes.
It's not related.
Maybe.
They're
Right.
cousins.
Continuing. So, we'll start at... It's projecting? Yeah. We'll start this lesson, Transformers. For Wong!
What? Please tell me what in that video about.
Leave
I know
video.
It's about
It was me dancing naked.
No, it's not. I saw a little bit.
Lee, I would not be happy with this.
Put my hand on the table and prove it wrong.
No, you said enough. Okay, Transformers now. So, we're continuing then with induction. Right.
Don't look.
So, in this lecture, we will study Transformers. Here's an example of one here. This one, this is Optimus Prime, correct? Yes. Well, usually his enemy is Megatron.
Yeah.
Megatron being part of
Decepticons.
Decepticons. Yes, correct.
He's the real Autobot.
Yes, correct. That's
What?
That's actually good.
Shut up!
That's actually it is. That's a good one. I'll remember that. Wong. I'll remember that one. Where did you hear that one? Or did you make it up?
No, from a teacher in high school.
Okay. That's a good one. Now, that's not really what we're looking at. Unfortunately, this is a transformer, not nearly as exciting. So let me just explain how the transformer here works. It's simple idea. What you have is, you have an iron core here, and on this side of the core, you have what's called the primary. And the primary wraps around many times. And then on this side of the core, you have a secondary. Now, think about what happens here. This will be an alternating current. So what happens when you have a current using the right-hand grip rule? What's around a current?
Field.
A magnetic field. Okay? Now, if this current is alternating, what does that mean it's doing? Changing direction. So now your magnetic field is changing direction. So this magnetic field is changing direction. What did Faraday say would happen when a magnetic field changes direction near a conductor?
We will make voltage.
It'll make a voltage. So what happens here is we will get a voltage here. But what's interesting is that the voltage we get here,
It's less.
well, in this picture it'll be less, but the voltage depends on the relationship between, the number of windings here and the number of windings here. Input and output. Now, in this particular example, Yusuf, you've spotted it, the voltage here in the secondary will be less than the voltage here in the primary. Now, transformers are very simple devices because you only need three things. A wire, a secondary wire, and just an iron core. So when you have something like
Source of AC.
well, obviously, because that's the thing you want to change, you know. Does anyone have their laptop battery here? I can show you.
Laptop battery?
Sorry, I mean plug.
Do you want a plug?
No, actually, I don't even need this part. I just need this. You all know. You all have one of these. You don't mind if I break it open?
No, go ahead, all yours.
Inside this is a transformer, probably. I mean, most electronics have transformers because the voltage here on the wall, wherever the plug is 220.
We have it working on
Fine. Whatever you have. Quite high. But the voltage this needs is maybe 5, 6, something quite low. So the transformer can take the voltage in at 220, so that would be, let's see which side, that would be this side. This could come in at 220 and then come out at something like 5 or 6 volts then.
That's all it means?
That's all here. Well, there might be other things in here, but I think the main purpose is to change the voltage. Like this one here, it usually says on it what it changes to.
No, but like 5 volts.
Oh yeah, that's low voltage appliance. I can't make it out, there's too much Chinese on it.
Why does this one?
Oh, here. This one takes in 220, or it can take in 110, it has 2 settings, and its output is quite a small 20 volts. So it reduces it by 10, 200 to 20 then, okay? Now actually, interestingly enough, the other maths teacher, which I think you might know, Joan, her previous job was she worked as a manager, an engineer, part of the management team of a company whose job it was just to make transformers. So she has a background in making these. And she said that they used to be in Ireland, but then it got too expensive, so they moved to Hong Kong. Then Hong Kong got too expensive, and then they moved to China. And what they would do...
They got bankrupt.
Possibly, I don't know. And now she works here. To make one of these, you need, at the time anyways, it's a bit of a pain because you need someone to wrap this around an exact number of times. Okay? So, for the exam, they will and could ask you to draw this. The key things are primary, secondary, core, and the flux. The magnetic flux is changing. Okay? Primary winding, secondary winding. Can you draw this, please? And we'll look at the formula shortly. Now, if you have an old plug at home that's quite big, think about an old phone, old TV, whatever. If you have an old plug at home that's quite big, it's probably because inside the plug is a transformer. If you wanted to, I would recommend breaking it open and you can see.
I don't think we got any old things with us.
No. If you're in a charity shop, you see an old phone.
Yeah, we'll buy it.
You could buy it just to break the plug open. Now, these transformers are actually pretty efficient, although they're not 100%. You'll probably notice with the older ones, this core can get warm.
Till now, that's all.
Even now, yeah. But they're quite good at making things smaller. So I think, your plug for your phone is probably looks like a regular plug. Everything is built inside of it. I don't even know if this is how transformers are made in new iPhones. I have a feeling that it's a bit more advanced than this now. I think it probably relies heavily on circuits and diodes and other capacitors to reduce the voltage than an old-fashioned iron core. That might work for an iPhone when it's small.
Not for an Android.
Well, certainly not for a Galaxy because it will explode. But for larger voltages, like in power plants, you would still need something like this. Okay. So let's have a look now. A transformer is an electrical device that transfers electrical energy between two or more circuits through electromagnetic induction. And electromagnetic induction produces an electromotive force across the conductor which is exposed to a time-varying magnetic field. Commonly, transformers are used to increase or decrease voltages of alternating current. So you don't need the last sentence. Really, you need these two sentences here. In fact, the first sentence is enough.
Sadly, they're also young.
I'll just ignore that so I don't have to report it to anyone.
Didn't do anything.
No, I know.
Only looked from far away.
Tell me you were that this was uploaded on YouTube again.
Dude.
What YouTube?
Leave him alone. He has issues to work through, okay? Leave him alone.
What's the iron thing called?
Just iron core.
Magnetic stuff.
Yep. Goes through the core.
Have to work on this math essay.
If only I told you 4 weeks ago it was due.
Yeah, even if
well.
I started 4 weeks ago, I would still have had to work on it.
True, but you wouldn't be under a deadline now.
It's not about the deadline, it's about work.
Oh, it's about the actual work. Oh, right, okay, fine. Okay, continue. Yeah. Now, I have a question. You might remember in semester 1 when we did electricity, we did something called a potential divider. Do you remember what the potential divider did?
Divide the potential.
And the potential multiplier?
Multiply.
Obviously.
Allows for an input voltage to be reduced.
Yes, the potential divider takes an input voltage and reduces it. So you might say, okay, well if we have a way to reduce the voltage using a potential divider, why do we need a transformer? What's so different about a transformer?
Efficiency.
Efficiency perhaps is one, but potential dividers are okay.
Expensive.
Perhaps it's the price, although a transformer will be more expensive because it's iron. So the
Distance for like it can transfer currents.
Oh, I see. Maybe it's a range thing or something. Yeah. Actually, the reason is transformers can be used to increase and decrease voltage. However, potential divider only decreases. So,
How can it increase?
yeah, that's what we'll have a look at now. So, step-up transformers.
Step down.
Step-up transformers
Increase the
1 or 2.
increase the voltage. Go on, have a guess at what the opposite is.
Step down.
You are correct. Decreases the voltage. Okay, so please note that vocabulary. And a step left transformer?
Ha 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 ha.
Thank you.
That's how he feels about you.
Yeah.
I know.
I get this all the time.
I have to act like I get his feelings sometimes.
Wait, what? It's an act? Wait, you've been faking this? See, for one, English isn't so hard. Okay, you got that? Yep. So, let's have a, well, we already looked at how it works, so I don't need to examine that. What we need now is a formula. How can we calculate the voltage? So let's have a look at the formula. And it's extremely simple. N1 and N2 are the primary and the secondary windings. V1 and V2 is the primary and secondary voltage. So this is N1 and this is N2, the turns. And here we have V1 and out we have V2. Yes, question?
Yeah, if you go back to the image.
Yeah.
Yusuf said that the voltage over here would be smaller on the other side.
This side, correct.
Yeah.
Because the
number.
N2, yeah, is smaller.
So if we increase the number of the windings
On which
the
side?
output.
Here, yeah.
Yes. But decrease.
Yeah, this is you made it a step up.
Yeah, if
So
it was
this
the
would
other way
increase the
around,
voltage.
yeah, you'd increase the voltage, yeah. So in here, where this is a step down transformer, or just if you just flip it around, you have it doing the opposite job then. Yeah. So this is our formula for a transformer. Quite simple, really. Very simple formula. I'm going to have a look at some examples now. There are other formulas too, but this really is enough. It's never 100%, but it's nearly 100%. So for most problems with transformers, we can assume it's about 100%. And if it's 100%, then we can say that the power in equals the power out. Now in real life, that's not true. Some energy is lost in the transformer process, but it's close enough, so we can say the input and the output power is the same. Therefore, think about this. If the power in equals the power out, then the current multiplied the voltage in equals the current multiplied the voltage out. Because this is, just the formula for power. Power equals IV. So you can say I1 over I2 equals V2 over I'll say it the other way. I2 over I1 equals V1 over V2. But what does V1 over V2 equal if I use the first formula? Yeah, N1 over N2. So you can get this formula that says I2 over I1 equals N1 over N2. So it's kind of like this formula. So now we have a way to work out the voltage and the current, as long as we know the ends. Yeah? Okay, can I continue? Yes?
I2 over I1 equals to V2 over V1.
Yeah, which equals N1 over N2.
No, V1 over V2.
V1 over V2, isn't that what he said?
He said V2 over V2.
Oh, V1 over V2, yeah. Continue? So, I think we're all ready to have a look at an example. I'll give you a short one to try. A small toy requires 6 volts. Dude, put the phone away.
Didn't see it.
Later. You can share your smutty, dirty pictures with him later,
No,
okay?
picture.
Video then.
It's a meme. It's a meme video.
Fine.
Oh.
GIFs then, whatever. A small toy requires 6 volts. It uses power from a 220 main supply. The number of turns on the primary coil is 4,400. How many turns are on the secondary coil? So which formula do you need here?
Count to 4.
N1 over N2 equal V1 over V2.
Good, okay, so calculate the N2, please.
120.
You have it done, yeah? Yeah, easy peasy. So,
Look, could you give me this?
Excited.
oh man, Right, what is the
That's where I
N1?
come from.
Yes, culture. N1, N2.
No, I come from Oman. The country, you know.
Yes. V1, V2. Alright, so what do we get for N2 here? 120. Good. Okay, continue. Yeah? Alright. Homework. So, a very simple lesson. You can start these now, please, for a couple of minutes, and then we'll have a look at the answers next time.
I'll show you.
Is it dirty?
No, it's not.
Okay. Funny. I like it though.
No, you're not getting it.
Yeah, I got it. Hit jab, low jab, mid jab. I got it.
He didn't get it.
Oh! Is that what it said?
Yeah.
I wasn't reading.
Yeah, we had a similar one in school when I was in high school, but you might not get it because it has to do with O.J. Simpson.
Okay.
Do you know O.J. Simpson?
Yeah.
Do you know O.J. Simpson? Yeah, what's he famous for now?
Orange is the new black.
No.
Well,
Yeah. Okay.
what's he
go on.
famous for? Infamous for? It was his trial for killing his wife, wasn't it? Yeah. So the allegation was he stabbed her. So our teacher said, "Oh yeah, he came in one day saying, oh, there's a new website for the O.J. Simpson trial if you want to look up about it." I'm like, oh, they're like, okay, what is it? It's ojsimpson.com / / / which are like, bad taste, but I like. Do you need me to go back to it?
I'm getting 1 over 120 for some.
You have this? So you need to bring the M2 up, the 6 up, the 220 down. So you have 440 over 220 times 6.
4,400.
Oh, sorry, 4400, yeah.